key to how Tekla Tedds calculations work is how Tedds stores the values used in those calculations. When you run a calculation, Tedds will store all the values that you specify. So for example here we're looking at a pad foundation, so it's going to store the length and the width of that foundation, plus the depth and all the other properties that we specify. And it will also store the calculated values, such as here the bearing pressure, both allowable and applied. And we're going to store them away as what in Tedds we call variables. And each variable has a unique name, a current value and a dimension. So name LX, value 1800 and dimension millimeters. These variables can then be used in subsequent calculations to calculate even more results. So for example our LX and LY are used here to calculate the foundation area, and the area will then be used in other calculations further on into the design. When you recalculate, Tedds will replace the variables you've currently got with the more updated set of information. And you'll see here that all the calculations are updated. You can view the list of current variables at any time, either from within the interface by clicking on the Variables button, which will show you a list of the current values, or you can do the same thing by clicking on the Variables button on the Home ribbon here in Tedds. The names will be listed in alphabetical order, with the lowercase names first, followed then by the uppercase characters and the Greek characters. And if you're interested in looking at a bit more detail at any particular value, you can just scroll through the list or type the initial letter of the character you're looking for and it will show you the information. And you can also group the information by dimension. The dimension will be shown in what we call Tedds base units, which is a combination of mass, which is shown as M, length L, T for time, or blank if it's a dimensionless variable or an angle. The actual base units we use for SI are kilograms for mass, meters for length, and seconds and degrees. So for example, a kilonewton is actually kilogram meters per second squared and will be shown as M1 L1 T to the minus 2. For US units, the base units are actually slugs, feet, seconds and degrees. So therefore a kip is a slug foot per second squared, which is also shown as M to the power 1, L to the power 1, T to the minus 2. We don't need to worry too much about that, that's just the way that the system works in the background. If any time you're interested in knowing what a particular unit is, you can hover over the variable and it will show you. So this is a stress, probably newtons per millimeter squared. Tedds will calculate using these base units, but display the final output in whichever unit is most appropriate. And this is how it can handle a mixture of units without lots of conversion factors or scaling factors that you would need, say, in Excel. All the common units and many uncommon units are available, but you can also add your own units if you can think of one that we haven't yet covered. When using Tedds to create a report with multiple calculations, each calculation should be within its own calculation section in order to retain the separate variables as discussed in previous videos. If you place your cursor in a specific calc section and look at the variables, you will see the variables associated with this specific calculation section. So in my case here I'm looking at north wall. If I move to the next section and look at the variables, this time I will see the properties for the east wall, and this is how Tedds keeps those calculations in separate lists. Tedds also comes with many system variables, things like pi and acceleration due to gravity, which don't need to be defined in any specific calculation. We also have many structural engineering defaults such as Young's modulus and shear modulus for various different materials, and even densities for different steels, different materials for different design codes. Once you understand how variables and calc sections work, you can start thinking about linking your various calculations together. For example, you could take the load from a steel column design through to a base plate design and then onto the pad foundation. And if the load on the column updates, you can have that variable trickle through the various calculations, updating all the designs from start to finish. You could also consider setting some default values at the start of your document that can then be picked up by the various different calc sections. A good example of that could be you might have a bearing pressure for your site and you want to design various different foundations, so you can set your allowable bearing pressure at the beginning of the document and allow it to be picked up by the various different foundation designs. But those two topics are perhaps a subject for another video. For now, the thing to remember is each of the values you define, or each of the values that are calculated, are stored away as a variable with the unique name, its current value and the unit, and it's that variable that can be then used throughout the calculation. I hope you found this short video interesting and you've learned a little bit more about Tedds variables that will help you with your Tedds use in the future. Thank you.